All right, today I want to take a look at mainly the diseases of the eye, of sight. And first of all, I'm going to take a look at the different things that the light goes through as it goes through your eye. If I start out with the picture that we took a look at yesterday, if I'm taking a look at light, coming through the eye, the first thing that's going to come in contact with is the cornea. That's that structure right here, the clear part of your eye. The next thing it's going to come in contact with is the aqueous humor, that very, very liquidy portion. The next thing it's going to strike or go through is the lens. Then it will go through the vitreous humor, that's the really gel-like substance. Then it will strike the retina, that's the inside tunica or layer of the eye. That's where all the receptors are. Then it would hit the choroid layer, and that is a very dark color, and it absorbs light. So that's the end of light. So light, if I'm going through, again, it would hit the cornea, the aqueous humor, the lens, the vitreous humor. It would go through the very, very thin layer of the retina, and that's where it is perceived, and then it would be absorbed in the choroid, and then it's done. Okay? All of those bend light or refract light. The only one that actually focuses it, again, is the lens, and we'll take a look at that a little bit later. Some diseases, and some of us have probably had some of these. What's a stye? Stye is basically an infected hair, almost like a little zit on your eye or on your eyelid. A conjunctivitis, a lot of us have had that. It's called pink eye, is what we usually call it. Conjunctiva, that's that little thin layer that is on the outside of the eye. And when it becomes infected by bacteria, the blood cell or the vessels constrict or dilate, and it looks really red. You take some medicine and it kills the bacteria pretty quick. Cataract is clouding of the lens. Glaucoma is when there's pressure built up in the eyeball. That's one of the things they check when you go into for an eye appointment. They do that little puffer, that little puff of wind or whatever that hits your eyeball. It's basically measuring the pressure. They're measuring how it bounces off your cornea, the air pressure. They're checking for the pressure inside there. Hyperopia is farsightedness. You can see far. Myopia is nearsightedness. You can see near and not far. Presbyopia, that's what happens with age. Your lens becomes stiff and it's not able to relax all the way, so you can't see close up. Most older people have corrective lenses, and if not, when you see them at a restaurant, they're holding the menu as far away as possible because they can't focus on really close objects. Amblyopia is a lazy eye. A lazy eye is when one doesn't want to focus. It makes the other one do all the work. A lot of times they'll patch the good eye and make the lazy eye do the work. A lot of times that fixes it. Diplopia, it's double vision. I had a cousin that got hit in the back of the head and he saw double vision for almost a year. Strabismus is when one eye is misaligned. And we probably all know somebody that has this. You're talking to them and all of a sudden you can't tell which eye is looking at you. They're not stereoscopic. They don't both focus on the same image. Nyctalopia is night blindness. These people have a hard time with the number of rods that are not sufficient and they can't see at night. The normal vision, the image is focused right where it should be on the back of the retina. One thing you should notice that the image from the top, so if I'm drawing a little guy here, not very well, the head would be down here and the feet would be up here. So actually we see what's called a real image. It's upside down and actually reversed. Your mind switches it so that it's right side up. In myopia, nearsightedness, it focuses it before the retina. In hyperopia, it focuses it behind the retina. So in those two, we use corrective lenses to focus it on the correct spot. Stigmatism, that's if my cornea is usually nice and rounded. If I go in with an obvious one, there'd be like a little flat place on here. So what would happen in this spot right here on my cornea, so if it's right there, a little flat place, then it would not bend light properly in that one place. So in the corrective lenses, you have to have a lens that's differential in the different areas to compensate for your bad spot. Okay, that lens, again, is the only thing that we can adjust or focus in my eyeball. And if I take a look at, here's the lens with the muscles around it. And what happens is, I always compare it to, this is like a trampoline kind of, where those springs are always tight and they're pulling the lens flat. And when it's relaxed, the flatter it is, that's for distance. So when I want to see closer up, I contract this circular muscle, and it makes the structure smaller, so the springs don't have as much tension on it. So let's say if I take a look at this, and you know how my drawings are, but I draw it flat, so I'm taking a look at it and I'm turning it, so I'm looking at it from the flat version. If the muscles that it's around it relax, this is going to be closer together and it's going to make this fatter. Okay, so if the muscles around it relax, this is fatter. That's to see close distance. And they show it here. This is the one that we'll take a look at. This one right here. So when I relax, the muscles relax, the springs on the trampoline get looser. Therefore, the actual lens gets fatter. And that's when I'm looking close up. So when I'm getting older, this lens is not as flexible, and therefore it can't get as fat, therefore I can't see as close. We usually do a little thing with the color blindness at this point in time. If you can see the numbers in all of these. Now, quite truthfully, this one is really hard to see it. I can see it, but a lot of people cannot. Take a look at those and see if you see numbers. I see 27 in that one. I see 1 in that one. I see a 5 in this one. I see a 2 in this one. If I take a look at these, three, 8, 6, 2, 6. You know, in the normal person, my receptors are differentiating the different colors in here, and some people are colorblind. They can't do that. I've got a brother-in-law who is very, very colorblind. I guess one of my sons, is colorblind too. All right, that's taking a look at the diseases of the eyes and the different things that the light passes through the eyeball. Tomorrow we will take a look at hearing. And first of all, I want you to read page 366 to 371 to get ready for that lecture. And if you haven't got your assignment in, get it in. And we'll talk to you tomorrow. Thanks.